this is where you have to be very, very, very careful. Because when you're solving equations, these equations have domains. And so when I look at this guy, I always going to have to go back to the original problem. These problems are all going to work with the properties of logarithms in some way. So that if I take a look, in order to do a single logarithm, this would be a sum, and a sum turns into a what? You look at your properties of log sheets. Sum turns into an addition, a product. So I have an addition turns into a product. So I need to bring these two together first. So this becomes log base 2 of, this is going to be x plus 2 times x minus 2 equals 5. And this is properties of logs. Now I need to rewrite. So this is going to say that 2 raised to the 5th power is equal to the argument. This is the one thing, if you can't do in your sleep, that's going to kill you on this exam, is being able to rewrite things from logarithmic to exponential form. So this is x plus 2 times x minus 2 equals 2 to the 5th power. Or that x squared minus 4 equals 2 to the 5th is 32. This is so cute you can tell it's a book problem. Or that x squared equals 36, or x is what? What's x? Plus or minus. Yeah, remember, you take the square root of both sides. Don't forget the plus or minus. So x is plus or minus 6. Now, that's not necessarily your answer. And you may say, well, why? Because that's why they say to check your answer. And you have to check it in the original problem. You don't check your answer here. You don't check your answer here. You don't check your answer here. You've got to go back to the original. It has to satisfy the original. Is it true if x equals 6, is it true that log base 2 of 6 plus 2 plus log base 2 of 6 minus 2, is that equal to 5? Log base 2 of 8 plus log base 2 of 4. It happens to be that log base 2 of 8 is 3, and log base 2 of 4 is 2, and 3 plus 2 is 5. And you can check that if you like. So x equals 6 is an answer. It checks. Suppose x equals negative 6. I have log base 2 of negative 6 plus 2 plus log base 2 of negative 6 minus 2. Is that equal to 5? This gives me log base 2 of negative 4 plus log base 2 of negative 8. What do I notice? It's a negative. The argument's negative. And what do I know about negative arguments and logarithms? Can't exist, right? So this is a no. Can't take log. of negative number. Now, I can have an answer which is negative, it just can't make the argument negative. I might have a large enough positive number that's going to wipe out that negative. Now, what is the issue? Oh, so my answer is just x equals 6. So the question is, what's the issue? So first of all, the solution must satisfy the original problem. If I look at log base 2 of x plus 2 plus log base 2 of x minus 2 equals 5, this argument says that x plus 2 has to be positive, or x has to be greater than negative 2. And at the same time, x minus 2 must be positive, or x must be greater than 2. So here the domain is x greater than 2. However, now look at log base 2 of, when we made the change using the properties of logarithms, that's the equation we solved after we made the property of logarithms changed. Well, if I want the domain of this guy, this says that x plus 2 divided by x minus 2 must be positive. Or our setup is x plus 2 has to be 0, and x minus 2 can't be 0. Or x equals negative 2, x can't equal 2. So on my number line, I have negative 2, I have positive 2, and I have open circles, by the way, because it doesn't include either one. And they're both multiplicity 1, so there's a change there. I'm going to pull a test point, namely x equals 0. And what do we have? Is 0 plus 2 over 0 minus 2 positive or negative? Negative. Cross positive, cross positive. Here's the domain of the one I changed. His domain is minus infinity to negative 2, union to infinity. In other words, that's how I picked up negative 6.
Bless you.
That's why you need to go back to the original problem. If this was the original problem, negative 6 would be a solution. And then you'd ask yourself the next question, well, why would that be? Well, if I have a quotient, I could have a positive divided by a positive. That's positive, correct? And I could have a negative divided by a negative. What's the case there? It's also positive. So once I made the change and I brought those two together, either as a quotient, whoops, I'm sorry, or as a product, I just screwed up, but the issue would be the same. I need to re-video that. Quotient or a product, I could introduce an additional solution. I could introduce an additional solution. In this particular case, it wouldn't have changed anything because this guy should have been a product instead of a quotient. Thank goodness. And then these would be both equal to 0 instead of not equal. And we would have ended up with the same thing here. And I don't know why I got a quotient into my little puny brain this morning. Okay, so if I check out 0, this would be 0 plus 2 times 0 minus 2, and it still would be negative. But that's the problem. When I bring them together using the properties of logarithms, I change the domain of the problem, the solution set, which is why you need to check your answers. By the way, the only thing I normally do is I take my answer, like I got here, 6. If I put 6 in for x plus 2, that's positive. 6 in for x minus 2, that's positive. That should be okay. Put in negative 6. Negative 6 plus 2, I get a negative or a positive number. Negative. That means it doesn't work, period, no matter what you do. It doesn't work in the original problem, but it works when you bring them together. Interesting, huh? Oh, maybe you owe it to me.